Hey, YouTube guys and girls. We're in East Texas today. This is Joaquin with Hammered Out Welding. I'm a testing and training facility here in East Texas outside of Tyler, Texas. I'm gonna talk about Oxyfuel usage today. Oxyfuel safety and application of using the different tools that you can with Oxyfuel. Now, one of the things I've noticed is so many people get used to having the regulators set up in the shop that they do not bleed out the lines, they do not back off the regulators. And a lot of times they leave the cylinders open, which that's all basically setting up for problems, safety issues, safety concerns, right? So very important that the system has been bled out, that the cylinders are isolated, and that you basically have no pressure in your hoses, okay, when you shut this down. All right, to set this up, I'm gonna talk about the different tips in which we can use on our Victor handle here. We have a rosebud, we have a cutting torch, we have a welding tip. Okay, they make different tips for different thicknesses. You go up with this handle and this setup, you go 3.5 to 4 inch thick of steel and actually weld it. Yes, multiple passes, of course, not at one time. Come on, you guys. Jeez. And then here's another tip. Look at this little tip. This little tip right here is a single aught. This is a little single aught. It's not going to cut the same thickness as the tip size that's in here. This is actually a number 2. Number 2 is going to be able to cut 1 inch thick material. That's the last I was using this for. A single aught is actually going to cut. When we look at our Victor reference card, very important. This has the pressures that you can set up, both regulators to set it up to be successfll using this setup. Okay, so single aught, 3/8 is what it recommends. Victor recommends that with a single aught, you could torch cut up to 3/8 with that number 2, 1 inch. Now, does that mean I could slap that number 2 and cut other materials? Yes, you can, but it's not going to have the same clean cut that you can get with the proper size tip, okay? I go to the metal yard and I see them using one size tip for all applications. Yes, that's true. And I've seen them actually torch cutting without safety glasses. So crazy. Oh, shade 5. Until you start getting up to these higher numbers, when you're actually torch cutting something thicker, using more heat, the flame is higher. Yeah, you go up in your size of shade. But typically, we're going to be cutting, say 1/2 inch to 1 inch. Shade 5 is going to keep you in a safe zone. Okay. So that said, let's get this set up. With these regulators, these are single stage regulators made by Victor. They have 2-stage regulators. 2-stage are more precise than single stage. You actually have 2 diaphragms on them, right? Single stage will work fine for most applications, and 2-stage regulators are if you wanted to even be a little bit better with your torch cuts. It's more precise control. Okay, so let's set this up first. Now, one thing is inspect the O-rings. There's 2 O-rings inside this handle, or I'm sorry, inside this torch tip. And when they go into this handle, they actually sit on 2 different seating areas. Make sure you inspect that, and I inspect my seating areas, make sure there isn't any debris on there. It looks nice and clean. When I put it together, this nut right here with these O-rings is hand tight, okay? I see guys coming in and they go to set this stuff up and they want to grab a crescent wrench and they want to tear it down, man. And it's hard on your O-rings. You don't need that. All right, so hand tight. This, on the other hand, is torqued down, 17 foot-pounds. Is what Victor recommends. This does get torqued down. And how am I going to torque that down? You use a crow's foot with a torque wrench if you want to be really precise. 17 foot-pounds is what this is torqued down to. Okay, don't over-tighten it. The other thing I'd say is don't over-tighten these regulators to the cylinders. That's another problem I see. When you do that, you can mess the seat up. Make sure the seats are clean before you attach your regulators, that there's not any debris. Now, something else you're going to notice is that on the fuel side, the regulators and the hoses are actually left-hand threads. And on the oxygen side, they're right-hand threads. And it's made that way on purpose to make sure you don't mix match. Never use a regulator that was used for fuel on the oxygen or vice versa, okay? These fittings do not need any Teflon tape or any pipe dope. No, they actually seat on two surfaces that are basically meeting one another, and under pressure, they're soft surface. It's a soft surface that's actually going into the cylinder surface, and they actually seat. It'll actually create an airtight seal. Okay, that said, now when we go to set this up, we're gonna crack these cylinders open. On the settle-in, notice I stand behind the barrier of protection here. I go crack this open nice and slow, and this is actually going to get open to, ooh, I tightened it up real tight. Basically 1 wrist turn. Victor recommends 3/4 to 1 revolution. Okay, if my thumb is in this position, look at that, about 3/4, just 1 wrist turn, that's it. That's all you want to open it, 1 wrist turn, okay? The reason being is you want to be able to isolate this valve if you have an issue. You want to be able to shut it off right away. Before I opened that, I didn't say anything, but I made sure these were tight, that these were actually isolated. These are my secondary valves. Primary valves or cylinder valves, secondary valves. I actually did this and didn't say, hey, make sure these are isolated. This right here, we're going to open this one all the way up, but this one is actually tightened down. This is our mixing valve right here. This is actually going to mix our oxygen with our acetylene, okay? These secondary valves, we made sure they were tight. Now we open this one all the way up, okay? This one here is isolated. Now we're going to open our oxygen. Crack it, and then open it up all the way again. I'm using the barrier of protection. I'm not looking at the gauges as I open them. And you check for pressure. Now, just so you know, if I hit this, I still don't have anything, you know, fuel's not going to come out right now. The reason why is that when we shut this down before, we backed off our regulators. That's why it's important to do that, okay? We backed them off. Now, check your Victor reference. We have a size 2 tip. We're going to set this up at 35 to 40 on our oxygen and 4 to 8 on our acetylene. Let's see, preheat oxygen, acetylene pressure. Actually on the acetylene, we're actually going 3 to 6. Okay, so 3 to 6. When we do that, you turn this in and you can see the gauge go up, right? Now when I set that up, I make sure that when it flows, it drops a little bit and it's staying within that zone, that 3 to 6, and it is. It's right at 5. Now, right here, we're going to set up our oxygen, and for a size 2, we're actually looking at 35 to 40. We adjust it in to that 35 to 40. And when I hit that, now, what I just did, I just purged the lines. Okay. So my fuel side and my oxygen side has been purged. Okay, so now it's ready to go. That said, when we strike this up, on the fuel side, we're gonna strike this up, and when you strike it up, what you're looking for is a nice uniform cone in the center where it's flowing smoothly. If it's spitting or sputtering, you have a dirty tip, all right? And it's going to be hard to hear what I'm going to say because I'm going to have to put on my shield when I go to strike this up. All right, let me grab my gloves. All right. Now, what I'm looking for, you see that all that carbon coming off? I want to turn this up until that carbon is gone. See how it's all nice and gone? Look at my tip. I got almost an inch there of a nice straight flame. Now, I'm going to turn my oxygen on. Now when I go to adjust my oxygen, I want the lever to press. And I turn it to where the blue just comes in. That's it. I turn it off, I isolate my oxygen first, then my acetylene. Again, when I go to shut it down, I isolate my oxygen, then my acetylene. I'm not going to do a demonstrative of torch cut today. All right, so that's how you set it up. When you get any thicker than 1 inch material, you want to preheat that material with the torch. I preheat it from the underside, okay? The reason why is that I'm cutting from the top side, all right? If you preheat it from the top side is going to get hotter before, it's going to get hot before the bottom side does. So preheat that bottom side. All right, so that's how you set this up. Now let's say we're done torch cutting and we're shutting this down for the day. I'm actually going to, the first thing I'm going to do is I'm going to isolate my cylinder valves, or what's also known as your primary valve, okay? So you come over here and you turn both these in. All right, now both cylinder valves are isolated. Next thing, I'm gonna purge out these lines. All the oxygen's out. All the fuel's out, the acetyleen's out. All right, now what I'm gonna do is I'm gonna back these regulators off. Now I don't have that unnecessary pressure on those diaphragms while it's sit. And if for whatever reason somebody comes to set this up and they open this valve up and this is open and this is turned in, the fuel isn't just running. Imagine if this is sitting over there on the bench or in a welding booth and somebody goes to set this up and they're not being safe about it, you know? They're not running through all these scenarios in their mind to be safe of what they need to do. And I know I didn't put my welding hood on for that Shape 5 when I started that flame up, but I knew you wouldn't be able to hear me if I did. You gotta always keep safety in mind, you guys. Okay, so that was the torch cutting. Torch cutting, this is highly oxidizing flame. Torch cutting is known as rapid oxidation, okay? That's what torch cutting is, rapid oxidation. Rust, when something rusts, just so you know, it's actually known as an oxidation reduction reaction to the material. Whoa, where did that come from? Okay, so the torch, we're gonna take this off. This is an oxidizing flame, right? Okay. Oxidizing flame. This is actually for welding. Welding is going to be set up as a neutral flame. Now, what does that mean is that the regulators will be set at the same pressure. Both of them, for this tip size, they're pretty close to both being set up at 5 psi. Okay, so it's a neutral flame. Okay, again, neutral, oxidizing. Now, rosebud. Rosebud is a heating flame. Right? We're heating it up. Guess what? This one, you want this one to be more of a carbonizing flame. Why? Well, you don't want it too carburizing. You don't want it to induce carbon into the material before you weld it. Definitely not. Not onto the surface. You don't want to do that. But you need to have more fuel on this puppy. Scratch what I said about carburizing. Now I got to edit this video. Okay. So this one here is actually going to be set up where you got to have the fuel at a sufficient level. All right. When you look at your Victor reference card, this has welding pressures. It has the actual pressures for torch cutting, and also has preheat pressures for rosebuds. I call it a rosebud tip. This is a size 8. So when I look at this, heating nozzles, size 8. For the acetylene pressure, 10 to 15, and for the oxygen pressure, 20 to 30. So it's not really a carburizing flame, because if it was, the fuel side would be higher than the oxygen side. So it's not really carburizing, and that's definitely not what you want when you're going to weld on something, because you don't want to induce carbon onto the material. But it has to run a rosebud. You don't want to overheat this tip. Because what happens is when you overheat the tip, it starts to snap back on you. It just pops out, pop, 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 pop. If you're getting that, you're running it too lean. Lean is mean, and it'll pop out on you. All right, so I hope this video helps you guys. Next video, I'll do some demonstrations coming up, but right now it's all about information. Very, very important on the safety of Oxyfuel usage is the pressure setup, the isolation of the valves. If you come into a problem, boom, you cut the hose on fire. What do? Which one do you isolate? You better isolate that oxygen, but that fuel can be isolated right away because it's only one wrist turn, right? Wrist turn that puppy off. Oxygen is still going to fuel that fire. You better isolate that sucker too, but this is one wrist turn. Bam! Shut that sucker off right away, right? very important, you guys. If this video's helped you, reach out to me, let me know in the comments. If it hasn't, it's too bad. Have a good day. I gotta go to work, man. I got work to do. You see what's behind me? This was from last week. This is this week. I just did this morning. I thought I better make this video for you guys really quick before I got too busy and I forgot about it. Last week, all this material was sitting on the ground over here and I told you how to get it done the following week. This is the following week. It's all built. Customer's gonna come pick it up either today or tomorrow and it's ready to go. You know, last week was a hot week. It was real hot in this shop. Stay cool, stay hydrated, stay safe. Talk to you later. This is Joaquin saying have a good day.